This is your pre-lab video for the separation of metal cations 1 and 2. So this is a 2-week lab. The objective for this 2-part lab is to successfully separate a mixture of 4 different metal cations. And once you separate them, you need to confirm that you separated them with these qualitative confirmatory tests. And once you have the separation scheme, you will perform the same set of separation steps on an unknown mixture of cations and identify which cations were contained in the unknown. In week 1, you'll perform reactions of all of the available solutions, perform the confirmatory tests on the known ions, and record the observations for all of these different reactions. Once you have these observations, you will use these to develop your own separation scheme for the 4 different metal cations provided. You will then need to hand in a flow chart of what your separation scheme is at the beginning of the next lab. In week 2, you will be performing that separation scheme that you developed on a known mixture of all 4 metal cations. You'll perform the confirmatory tests to make sure that your separation scheme worked and record your observations. You'll also then repeat that procedure on an unknown and identify the cations in your unknown solution. So how are we going to separate these cations? We're going to use solubility and differences in solubility to separate these cations. So we will precipitate out one or more cations to be able to separate it from what doesn't dissolve. The materials that are available will be aqueous solutions of the 4 metal cations that you need to separate. So you'll have individual solutions of all 4, and you'll also have 6 molar solutions of hydrochloric acid, ammonia, and NaOH. So precipitates, if you can precipitate one or more of these metals into a solid, you can separate them from anything that did not dissolve or from your soluble ions by centrifuge. You'll need to come up with a series of steps that will ultimately end up with the cations in each of their own test tubes. And they also have to end up in aqueous form in order to perform the confirmatory tests. So during week 1, you'll fill out this table 1. So you'll have each of the ions, right? So you have a solution of each of these ions, and one at a time, you will react them with the other materials. So you will perform a reaction of hydrochloric acid and aluminum, and you'll record your observations of what you see. Did you form a precipitate? And you want to use these solutions stepwise. So add a little bit, record your observations, then add a little bit more and see if you can maybe force a precipitate out that didn't come out just with a few drops. So don't just give up, don't just add a little bit and then leave it. You want to make sure that you get all of the observations that you can. You'll also fill out table 2 during week 1. So once you have which solutions and which mixtures form precipitates, you need to record what the precipitate is that you're making. So let's say iron and hydrochloric acid did make a precipitate, then that would make the precipitate of iron chloride, and you would write the formula in here as well. And then once you have your iron chloride, you will isolate it, meaning you will isolate your precipitate by decanting off the solution, decanting off the top solution, and then washing that solid with water. And then once you have a isolated solid material, you want to then try to redissolve that material in one or more of these other solutions. So with our example, it was iron chloride. So let's just pretend that that's a solid, and that was one of our solids from the other table. The ion would be iron. Reagent from table 1 would be the hydrochloric acid, and then our precipitate would be iron chloride. So then you try to redissolve it. Of course, it's not going to redissolve in the HCl. That's how you made the precipitate in the first place. But you want to see if you can dissolve it in NH3 or NaOH. So you'll test that to see if you can redissolve them. And you'll repeat with any of the solids that you make. Now the fact that there's 5 here in this table doesn't mean that there's necessarily 5 precipitates. There may be more or less, but you will list each of the solids here and then try to redissolve them. And the reason you want to see if you can redissolve them, you can kind of picture making a precipitate and then separating the pellet, which is when you centrifuge, it's the solid material at the bottom, from the supernatant, which is the solution at the top. So you can picture having your ions dissolved in the solution and then also as part of a compound in the solid. And you can kind of picture making that separation. But let's say we make two solids. We have a mixture of four ions, and two of them become solids and two of them are in the solution. We still need to be able to separate those two solids from each other. And if we can selectively redissolve one of them, now we can separate them. So that's one reason why it's important to find out how you can redissolve these ions. The other reason is that we can't perform the confirmatory tests on the solids. We need to redissolve them and have them in solution to perform the confirmatory tests. So that's why we need this information during week 1. During week 1, you'll also perform these confirmatory tests on individual solutions of just one ion at a time. So you'll perform the method, it's right in the lab manual, how to test for example, for aluminum. It gives you the stepwise, what to do to test for aluminum. You'll do that using the solutions of just one known cation, so you can record what that confirmatory test looks like when it is positive. So, for example, for aluminum, you will add a few drops of the solution containing the aluminum ion, and you will make it acidic with 6 molar HCl. Okay, so just a few drops of that. Then you will add a drop of this dye. Okay, that's just part of the test. Then it says add 6 molar ammonia dropwise until the solution is basic to litmus paper. So to test for basicity, we need to test with a red litmus paper. And does the red litmus paper turn blue? And the way that you do that is you insert your glass stirring rod into your solution, mix it up, and then bring it out and touch it to your litmus paper. Don't put your litmus paper down into your test tube. Okay, so once red turns blue, you know it's basic. You don't want to add any more ammonia than you have to. And if the aluminum is present, you will have a precipitate that's red. Okay, it absorbs this red dye and becomes what we call an aluminum lake. So each of these tests will be unique, and you will perform these on week 1 and get your observations so that you know what they look like. At the beginning of week 2, you need to hand in your flow chart of what your separation scheme is. You need to be very detailed and you need to be neat. Okay, so include things like what materials am I using, in what amounts am I using, and amounts I don't mean by specific quantitative amounts, but do you just add a couple drops or do you make sure that it's in excess? At what step do you centrifuge? And what will be in the pellet, which is in the bottom, the solid material, and what you expect to be in the supernatant, which is the solution above it, what the formulas are of the precipitates that you're making, and how this whole scheme is going to separate all 4 of these ions. So that's due at the beginning of week 2. So in week 2, you will perform and test your separation scheme on a mixture of all 4 cations, and this will be considered your known solution. You need to record detailed observations and what method steps you're taking. You will confirm the effectiveness of this method with your confirmation tests or confirmatory tests. So you will perform the separation, do your tests, and make sure that you were successful in separating all 4 of the cations. Once you are successful, you will then perform the same scheme or any modifications that you had to make on your unknown solution of it will be either 2 or 3 cations in your unknown. Again, you have to record very detailed observations and method steps, and then using the results of your confirmation tests, you will identify what cations were present in your unknown. The report. So you will have one report due after the 2 weeks. It's worth 20 points and cannot be dropped. You have to complete a written formal lab report. And make sure that you include all of your observations that you made for your known and unknown in your data section. Also include the 2 tables that you made during week 1 to come up with all of the information that you needed to generate your separation scheme. Make sure you write down your unknown number in your notebook as well as in your formal lab report. And when you specify what ions are present, make sure you specify also which ones are absent. So you should have a list of all 4 cations and whether or not they are present or absent in your conclusion section. And then after your conclusion, write a section that answers all of the questions that are contained in the lab. So don't forget the questions. And that concludes your pre-lab video.